So in the IJP, you guys, something like you joined as a Linux engineer, but so there is a vacancy in AWS or DevOps. So that post will be in only IGP people, means you have a knowledge, you have a experience, you have a knowledge on DevOps. So you guys can apply this post. You can directly move from Linux freshers to Linux to DevOps. So Linux to DevOps. Understood? సో ఈ 1 hour 2 hours ఏం చేస్తారంటే జాబ్ సర్చింగ్. సో జాబ్ సర్చింగ్ మీద కాన్సన్ట్రేషన్ చేయండి. సో వాక్ ఇన్ జాబ్స్, either walk in or something like online or whatever it may be, you guys can apply the jobs. You guys can apply the job. So I will show you tomorrow or day after tomorrow how to apply a freshers jobs. Okay. So resumes, are you prepared your resumes, right?
Yes, sir. Basic resume.
Basic resume. So Pawan, I think so Pawan resume is looks good. You guys can get it from Pawan and you guys can modify accordingly whatever you want. Okay.
Okay, sir.
And LinkedIn profile. First, you guys can create a LinkedIn profile and search the Linux and AWS and DevOps freshers. Okay.
Okay, sir.
Okay, na? So this is day 1. So I want you guys follow 1 week. Follow 1 week. So day 1 to day 7 and give the results and give the results to me. Okay. Definitely you will get the results, guys. Definitely you will get the results. So dedication, hard work, dedication, hard work. So sometimes intelligent people fail, but hardworking are so something like hardworking people never fail. Okay, guys. Understood. Yep. So come to
Yes, sir.
the classes. So what we did, guys, so we did the blue green deployment model and the configs and secrets also done, and stateless stateful also done. So Helm charts. So what is Helm charts, guys? Helm chart is like as a in Linux. So Pavan or Avinash. So what is a Helm chart? Forgot, huh?
Package install.
So package, I want to install a package on a Kubernetes or something like a container. So how you can install container is a something like it's like a is an image. So it's a 1 GB of image. So it's not a server, right? It's a container. So how you can install the package on the containers by using Helm. By using Helm. You already knows, right? We already discussed the Helm, right? We already discussed metric servers, something like Kubernetes. Not Kubernetes, Grafana and Prometheus also we discussed, right?
Yes, sir.
ESLI also we discussed. So auto scaling, I think auto scaling also we discussed, right? Horizontal scaling, vertical scaling, this is also we discussed. So requests and limits, this is also we discussed. So we discussed, yeah. So ingress. So ingress, we need to discuss about the ingress, but I will give you a little brief intro about that auto scaling also. Okay, today because of yeah. So what is auto scaling, guys? So what is the Kubernetes? Why Kubernetes is popular? So why Kubernetes is popular, guys?
Auto healing and auto scaling.
Yes, very good. Sunny, superb. So what is why Kubernetes is popular? Auto scaling, and auto healing. So auto healing is done. So how we can achieve auto healing, guys?
Through
How we can
replica set.
achieve? Yes, very good. Replica set or replication controller. Very good, Sunny, very good. So auto scaling. How we can achieve auto scaling? Auto scaling means if traffic comes, so we need to increase the containers, we need to increase the pods, right? So how we can achieve? We can achieve by using the auto scaling. So by using auto scaling is a way. What is auto scaling? Auto scaling is a way to automatically scale up or scale down the number of compute resources that are being allocated to your application based on the demand. So what is that, guys? Based on the demand. So for example, guys, so what is that movie? That movie is Kalki. Kalki movie. So I want to book the ticket for Kalki movie. Okay. So on which portal? Book My Show. So it's enabled it from. So the movie will start. The movie will start at next Monday, but they are opened for the movie tickets from Wednesday. So it's a big movie, right? So everyone can trying to access the application. For example, that application is support usually daily. How many people are accessing that website? For example, 1 lakh people is accessing that website. But that Kalki movie is so it released as a pan India movie and around the globe or world. So everyone can access that website. So it is only sustained for 1 lakh, but so at a time, how many people are accessed that website? So 10 lakh hits comes into that Book My Show. So is it support, guys, or it will hang?
It not
It will
supports,
hang,
it will
sir.
crash.
It will crash because of, so it supports the user limit only 1 lakh people. So the access of the application only 1 lakh people, but at a time 10 lakhs people are accessing this website. So definitely they will crash or they will hang. So I want to resolve that issue. So how we can achieve that? How we can resolve this issue, guys?
By increasing pods.
By increasing pods. By increasing pods means, so so the pod 10 pods are 10 pods are there. So every pod can sustain 10 10,000 people only. 10 pods are there. So usually 10 pods are every day 10 pods are up and running, and so it will sustain only 1 lakh. So I want to achieve a 10 lakh. So that time we need to increase the pods, right? So increase the pods. Increase the pods means our application will be deployed on the another 100 containers because of 10 lakhs people, right? So how we can achieve? So we can achieve, so something like a request under limits. Requests and limits. Requests and limits is nothing but a CPU. How we can calculate the performance? How we can calculate the people are increasing based on the CPU or memory, right? So it will hit definitely the processor will take the resource. So that time, so the CPU will increase automatically. So what you can give the threshold to the CPU memory. So something like if 30% increased, your CPU 30% increased on the pod, definitely you can increase another pod. So something like same like as a pod. So if 30% increased, it automatically scale up the another pod. If 30% it decreases to below 30, definitely it will reduce the pods. That is nothing but a auto scaling. Auto scaling is a way to automatically scale up or scale down the number of compute resources that are being allocated to your application based on the demand. So based on the demand. So auto scaling, how HPA works. So horizontal pod auto scaling. What is that, guys? Horizontal HPA means horizontal pod auto scaling. Here auto scaling will be two types. So one is a vertical pod auto scaling and horizontal pod auto scaling. But Kubernetes supports only horizontal pod auto scaling. Horizontal pod auto scaling. For example, this is your metric server. So your metric server is enabled the HPA, horizontal pod auto scaling, CPU memory utilization, above the target. If target reaches, it automatically scale up. If target decreases, it automatically scale down. Scale up and scale down increases the number of pods. You understood? So auto scaling. So install a metric server, deploy a sample application, create a service, deploy a HPA, horizontal pod auto scaling, increase the load and monitor the HPA events. So HPA events. So tomorrow I will create my cluster setup, guys, and will show you. So auto scaling, more users accessing this app, less users accessing this app. If more users, it will automatically increase the pod. Auto scaling. It is the process of increasing, decreasing infrastructure based on the demand. It is the process of increasing, decreasing infrastructure based on the demand. Auto scaling can be done in two ways. Auto scaling can be done in two ways. Horizontal auto scaling and vertical scaling. Horizontal scaling means increasing the number of instances or systems. So horizontal means increasing the number of instances or systems. Vertical scaling means increasing the capacity of the system. For example, your server have a 128 RAM, 128 RAM and 1 TB hard disk. But that server is supports 256 RAM and 2 TB hard disk. So if you increase the capacity as a resources, vertical scaling means increasing the capacity of the system. Capacity means 120 RAM to 256. So 1 TB to 2 TB. That is nothing but a scaling, vertical scaling. So what is horizontal scaling? So we need to increase the servers, instances. For example, only 2 instances are there. So we need to increase the another 2 increases. So Kubernetes supports horizontal scalings. Kubernetes supports horizontal scaling. So auto scaling, horizontal HPA, horizontal pod auto scaling, vertical pod auto scaling, horizontal pod auto scaling and vertical pod auto scaling. Guys, understood? So Kubernetes supports only horizontal pod auto scaling. Horizontal pod autoscaler, which will scale up or scale down number of pod replicas of deployment, a replica set or replication controller dynamically based on the observed metrics. So what are the observations? CPU memory utilization. How we can calculate that CPU memory utilization? By using requests and limits. I will show you guys requests and limits. HPA will interact with the metric server to identify the CPU memory utilization of a pod. HPA will interact with the metric server to identify CPU memory utilization of the pod. So HPA, how you can interact with the metric server? So to identify the CPU memory utilization, I already told you, right? Based on the CPU memory utilization, if you want to increase the pods or if you want to decrease the pods, based on the CPU memory, based on the limits and request. So for the production, we will use horizontal scaling only. In the production, so we will use horizontal pod scaling only. Yeah, horizontal scaling versus vertical scaling. Horizontal scale is nothing but horizontal scale is nothing but we can increase the instances, but vertical scaling increase is nothing but so we can add the additional resources. So while horizontal scaling refers to adding additional nodes, a vertical scaling describes adding more power to your current missions. More power to your current motion. So how we can calculate, how we can achieve this auto scaling? By using requests and limits. So by using a request and limits. Yeah. So configuring requests and limits in our Kubernetes deployments. Configuring. So limits, request. Okay. So limits is nothing but a maximum resources. So limits are the maximum resources that can be utilized by a container. If container exceeds this quota, it forcefully killed with a status of OOM killed. So the other resources mentioned in the limits are not guaranteed to available a container. It may not be fulfilled depending upon the resource allocation situation on the node. Right? You guys see. So the container resources, what are the resources guys? Limits and request. So this is maximum capacity, this is minimum capacity. So this is a minimum and this is maximum. If maximum comes, so we can add another pod. If minimum comes, it will delete the pod. Guys, understood? Based on the request, limits and requests. So limit is nothing but a maximum, request is nothing but a minimum. So request is nothing but a minimum. Guys, understood?
Yes, sir.
Yep. Yeah. So ingress. So what is the ingress, guys? So ingress is used to map external URLs to Kubernetes cluster services. Kubernetes cluster services. For example, so these are the three. So these are the 4 or 5, right? These are the 5 pods are running. So 5 pods are running. So if I hit, the application is running on everywhere. Something like this is a WhatsApp. So WhatsApp, right? WhatsApp. So this is the WhatsApp. So this is a WhatsApp. So WhatsApp is running on here, and the WhatsApp is running on here. The WhatsApp is running on here. The application code is running on here, and the application code is running on here, and the application code is running on here. Right? So if you hit the www dot website, www dot, so www dot web dot whatsapp.com. So whenever you hit this URL, it automatically searches where our application is deployed. So right. So first we need to get it in the ingress controller. So ingress controller means we will provide the load balancer. So in this ingress controller, so whenever you hit the web.whatsapp, right, it comes to here, here. So where the resources available, it will goes to the through the ingress controller. Or we can go it through the ingress controller. Okay. So ingress is used to map external URLs to the Kubernetes cluster service. So it will map the external URLs. Pods are accessible within the cluster. To expose pods outside the cluster, we are using the service called as a node port or LBR. So we have 3 types of services in cluster IP, node port IP, LBR, load balancer. Right. So ingress is used to map external URLs to the cluster service. So pods are accessible within the cluster. So same thing like, so first domain is your www.facebook.com, whatsapp.com or something like youtube.com. Then it will go to the ingress. Then it will go to the services. Then it will go to the pods. Then it will go to the pods. So what are the services? Node port service, LBR services. LBR services. Domain and ingress. Ingress is nothing but a LBR load balancer. Once you get the here, it will route to the services. Something like it will route to the hotels, it will route to the trains, or it will write to the flights. For example, so what is that? Make my trip. Make my trip having the 3 modules. One is hotels, trains, and flights. So whatever you want, you can go that side, right? So what we discussed about the container, pod, namespaces, clear volumes, so replication controller, replication set, daemon, stateful, deployment, so and ingress, so everything we discussed. So but we show you tomorrow that metrics, how to install the metric and how to install the Helm charts. So we'll show you tomorrow and we'll wind up tomorrow, guys, that Kubernetes. Then we will start the, yeah. So you already know everything, you already know some of the tools, that tools we use and we can automate the process. So we already know all the tools, but CI/CDs. So tomorrow we'll start, maybe tomorrow, tomorrow. So we'll start the CI/CD. So continuous integration and continuous string in deployment. So if you use all the tools and so we can automate our application deployment, or you want to build the infra through automate, how we can achieve. So we'll start from the day after tomorrow. So that Jenkins CI/CD. So we'll install the Jenkins, or we will install the GitLab CI/CD, and I will show you how to deploy our application, how to automate our application process. Okay, we'll show it on tomorrow. Guys, understood? So meanwhile, what you can do, you can practice the previous classes. Practice the previous classes. Okay, guys, so tomorrow class from 7 to 8, same as usual. So 7 to 8, and we'll let you know Saturday, Sunday. So most probably we'll take on Saturday, Sunday also, guys. You guys can plan it. Okay, so either morning or also morning or evening, you guys tell me your time. So I will schedule it and I will take the class on Saturday, Sunday also. Most probably we will complete next week the batch. Okay, so I want to show you a real time, guys. So please let me know your availability so that I will come to the institute and I will show you real time. Okay.
Okay.